Here we have a set math problem. Okay, let's go to the question. In the xy plane above, the graphs of functions f and g intersect at points b and c. What is the area of quadrilateral abcd? So here we have to find the area of this quadrilateral abcd. Okay, when you look at the quadrilateral carefully over here, the two sides of the quadrilateral AB and CD, both of them are perpendicular to x-axis. Whenever two lines are perpendicular to the same line segment, then the two line segments must be parallel. Since both AB and CD are perpendicular to x-axis, this AB and CD must be parallel. Since a pair of sides of this quadrilateral are parallel, then we have to consider this quadrilateral ABCD as a trapezoid. So for this trapezoid, these two are the bases because these two sides are parallel, and we can consider this AD as the height of the trapezoid. Okay, since we have decided this ABCD as a trapezoid, we can use a formula to get area of a trapezoid. Let me write the stuff over here. Area of a trapezoid, let me write it. So area of a trapezoid equals to 1/2 times height times A plus B. Here h is the height and A and B are the lengths of the two parallel sides. That is, we can take this A as the length of this side AB and this lowercase b as the length of this side CD, and h is the height that is given by the length of the line segment AD over here. Okay, now we need the length of this AB, CD and AD. So how do we have to get these lengths? For that, we have to find the point of, the 2 points of intersection of the two functions f of x equal to x square and g of x equal to x positive 2. The 2 points of intersection are B and C. So for that, we can replace this f of x by y and this g of x also by y. Okay, now to find the points of intersection of these two graphs, we can say that y equals to y. So for the y on the left side, we can consider the stuff in the first function, that is x square. We can plug in x square for the y on the left side. For this y, we can consider stuff in the second function, that is x positive 2. Okay, now let's solve for x in this equation. Actually, it's a quadratic equation. To solve for x in this quadratic equation, let's write this quadratic equation standard form. That is, we have to get everything on one side of the equation, and the other side we must have 0. Okay, let me subtract x and 2 from both sides. Let me do the same thing on the left side as well. So this positive x, negative x will cancel out. Positive 2, negative 2 will cancel out. On the left side, we have x square, negative x and negative 2. On the right side, we just have 0. Okay, now we have this quadratic equation standard form. I think we can try to solve this quadratic equation by factoring. For that, we have to multiply this constant term negative 2 by the coefficient of x square. In this case, it's 1. When I multiply negative 2 by this 1, I'm getting negative 2. So now I have to get two factors over here, so that the product of the two factors equals to negative 2. And when I add these two factors, it must be equal to the coefficient of x. In this case, it is negative 1. So I think negative 2 and positive 1 will work. When I multiply negative 2 and positive 1, I'm getting negative 2. When I add them, I'm getting negative 1, which is the coefficient of x over here. Now we have to divide. Further, we have to divide both these factors by the coefficient of x square, that is 1. Let me divide it. Even when I divide this negative 2 and positive 1 by 1, still I'm getting the same values, so negative 2 and positive 1. Okay, now usually when we solve a quadratic equation, we'll be getting two values for the variable. So in this quadratic equation also, we'll be getting two values for the variable x. Now to get the first value of x, I have to change the sign of the first factor over here. It's already negative. When I change the sign, it will be positive 2. Now to get the second value of x, I have to change the sign of for this factor. It's positive. When I change the sign, it is a negative. Okay, so that is negative 1. Okay, now I got the two values of x. One is x equals to 2 and the other one is x equals to negative 1. Okay, now to get the corresponding values of y, what we can do is we can plug in these two values of x either into the first equation, y equals to x square, or y equals to x positive 2. Okay, now let me take the second equation over here, that is y equals to x positive 2. Okay, now I'm going to plug in x equals to 2 and also x equals to negative 1 in this equation to get the corresponding values of y. Then we get y equals to 2 positive 2. When I plug in x equals to 2 over here, then we get y equals to 4. And now I have to plug in negative 1 for x over here. Then I'm getting negative 1 positive 2. So y equals to negative 1 positive 2 is just 1. So the first point is going to be 2 comma 4. That is x coordinate is 2, y coordinate is 4. The second point is the x coordinate is negative 1 and y coordinate is positive 1. Okay, now, so in these 2 points, these are the 2 points of intersection of the two graphs. Okay, so here at point B, which one can be considered, 2, 4 or negative 1, 1? Clearly, we have the point B on the left side of y-axis. On the left side of y-axis, the exponent must be negative. So in this point, the exponent is negative, that is negative 1. So we can consider negative 1, 1 as point B. And here exponent is positive, so we can consider this point 2, 4 at C over here. Okay, so here the exponent is negative 1. So since the exponent is negative 1, this gives the length of the horizontal line segment OA over here. When I consider the length over here, we have to consider this exponent negative 1 as positive 1. So that is the length of this OA is positive 1. Okay, now let's consider the exponent of the points over here, that is 2. Then the length of this horizontal line segment OD is 2. So when if I want to get the total length of AD, that is the height of the trapezoid, 1 positive 2, that is equal to 3. Okay, now we have the height of the trapezoid. Now let's get the lengths of the two parallel sides AB and CD. Now to get the length of this AB, we have to consider y coordinate over here, that is 1. So the length of AB is 1. And now to get the length of this CD, we have to consider y coordinate over here, that is 4. Okay, now we have the lengths of the two parallel sides 1 and 4. And also we have the height of the trapezoid, that is 3. Okay, now in this formula, I just have to plug in the lengths what I have found so far. Okay, let me continue over here. That is 1/2 times. Now for height, we can plug in 3. Let me do it. And for A, that is A and B are the lengths of the two parallel sides. That is 1 and 4. We can take 1 for A and 4 for B. Then we get 1/2 times 3 times 4 positive 1 is 5. Okay, so when I multiply 1 times 3 times 5, I am getting 15 divided by 2, which is equal to 7.5. So therefore, the area of the quadrilateral ABCD is 7.5 square units.